All right, so we're going to be using these formulas to solve some different problems. So there are a few problems that we may jump back to later that are earlier in the section, but I feel like you might be confused if we start with that. So we're going to start with some different ones. So number 42 is the sine of 255 degrees. Now, is 255 degrees on the unit circle? No. So what I'm looking for are two angles, which are going to be U and V, that when I add them together equal 255. And there's going to be a lot of different combinations that can work, but anybody see any that? 225 and 30. Yep, we can do that. So we're going to write this as the sine of 225 plus 30. And it can also be, I didn't say this, but it can also be angles that are being subtracted. So it could have been like, 300 minus 45. Like that also would have worked. Because those are also known angles. So anyways, but we're going to do the adding one for right now. So that formula is going to be the sine of u. So the first number is going to be u. Second one is v in the formula. So it's going to be the sine of 225 cosine of 30. And those things will be multiplied together. Plus, same sign for sine, cosine of 225 sine of 30. So now this is where the unit circle comes into play. I need to know what the sine of 225 is. So remember, that's the y value at 225. So what is that? Negative root 2 over 2. And what is the cosine of 30? It's the x value.
I have root 3 over 2.
Root 3 over 2. Plus, what's the cosine of 225? Cosine. Negative root 2 over 2. And what is the sine of 30? Yep. So then now I just need to multiply the things together and then add them if possible. So negative root 2 times root 3 is what? What's negative root 2 times root 3? Yep, negative root 6 over 2 times 2 is 4, plus, this is going to be negative root 2 times 1, which is just negative root 2 over 4. And now, because those have the same denominator, I can combine them. So it'll be negative root 6 minus root 2 over 4. Now, all of your answers to these problems, okay, the sine and cosine ones, I should say, should look very similar to this, okay? The numbers that are there, some combination of root 2, root 6, and 4 are always going to be what you have, because every x and y value for sine and cosine is something over 2, so it's always going to end up being something over 4 for your final answer, and then it's some combination of root 2's and root 3's multiplied together and 1's to give you the top part. So if your answer doesn't have these combination of numbers in it, doesn't have to be in that order, doesn't have to have those signs on there, you're probably wrong and you should go back and look again. Okay. Let's do a tangent one. So mathematically, the tangent ones are the hardest. Okay, because it involves a fraction and then fractions and fractions. But we've got the tangent of 285 degrees. So I need two angles that I can either add together or subtract from each other that give me 285 degrees that are off the unit circle. So any suggestions?
40 and 45.
What'd you say?
240 and 45.
Yep, that'll work. So the tangent of 240 plus 45, I had thought you said 40 and 45, and that's why I was like, what? So 240 and 45. Whoa, what is happening? Okay. All right, so using the formula for tangent, why did I just flip off that page? I need that. So we've got the tangent of 240, same sign on top, so plus the tangent of 45 divided by 1 minus, because opposite sign on the bottom, tangent of 240, tangent of 45. So remember, on the unit circle, the tangent values are the ones that are the most outside. So they're the ones that are some combination of either 1 root 3 or root 3 over 3. So what is the tangent of 240? Root 3. So root 3 plus the tangent of 45. 1 over 1 minus, and then since we already said them, root 3 times 1, which obviously is just going to be root 3. So I've got root 3 plus 1 over 1 minus root 3. And here people get tempted to start crossing things out, but we can't do that because they're being added together. So I need to do something to get rid of the radical on the bottom. Okay, now I'm going to erase this just so that I don't have to rewrite it, but so we can see it. So now, does anybody know or remember how I can get rid of a radical on the bottom when it's something like 1 minus that?
You do it on both top and bottom.
Do what?
Multiply.
By what?
1 minus root 3.
Change the sign.
1 plus root
1 plus root 3, because we want to get a conjugate pair that will allow us to flip the sign to get rid of it. So we're trying to make a difference of squares on the bottom. So I'm multiplying by 1 plus root 3 top and bottom. So on the top, I'm going to have root 3 plus root 3 times root 3 is just going to be 3, plus 1 plus 1 times root 3 is root 3. Over on the bottom, this has made a difference of squares for us, so it's going to be 1 minus root 3 times root 3 is 3. And so then on top, I've got 4 plus 2 root 3 over 1 minus 3 is negative 2. But I'm not done. This is where I can take a 2 out of the top. So I'm going to pull a 2 out from up here. So it's going to be 2 times 2 plus root 3 over negative 2. And now I can cancel. Okay, people are tempted to just, at this point, to cancel here and tell me that that's going to make that a -2. But because these are being added, that's not true. I can't do that. I've got to pull it out first, like I did here. So then, whoops. 2's are going to cancel. And then I'm going to have negative parentheses 2 plus √3. Like that. And that'll be my final answer. And so, just like I told you that all the sine and cosine ones should be some combination of like √6, √2, and 4, all of your tangent ones should be some combination of like 2 and √3 or something like that. Sometimes I think they might come out to be fractions in the end, but usually everything cancels down, so it looks something like this. Now, obviously, might be positive, might be negative, but something along those lines. And fortunately, you picked angles such that we didn't have fractions and fractions, but sometimes that does happen and you have to keep change flip if that occurs. Why are there not cosine ones? There's no cosine ones. Okay. Let's do another sine one, but it's a little different. 50. The sine of pi over 12. So this is where yesterday we made that note that if it's in radians, most of the time we're going to want to convert it to degrees, because I wager you don't know what radian values off the top of your head to combine, to add or subtract, to give you pi over 12. Because no values on our unit circle are increments of pi over 12. Okay? So I would say the first thing you should do is to convert from radians to degrees. This is good practice because the lady that was here last week doing SAT prep with you told me that this is one of the things that could be on your SAT, is how to convert from radians to degrees and degrees to radians. So, and it was a fill in the blank question in her practice book. So, good little refresher here. So pi over 12. Does anybody remember what my conversion factor is to convert from degrees to radians? 180 over pi. And so remember, if we were going from degrees to radians, it would be pi over 180. Since we're going radians to degrees, it's 180 over pi. We're trying to get units to cancel. So pi's are going to cancel here. And then 180 divided by 12 should be 15, I think. But anyways, at that point, you can just type it in. But it should be 15 degrees. So now, there's not two angles that I can add together, because adding, I would have to have two angles that are smaller than 15 that I can add together, and I don't. So now I need two angles that I can subtract and give me 15. Yep, and you could do anything. You could also go do 225 minus 210, but I try to keep it in quadrant 1 because those are the easiest numbers to work with if possible. So this is going to be the sine of 60 minus 45. So formula is sine of 60 cosine 45, same sign, minus cosine 60 sine 45. So what is the sine of 60 degrees? So y value. sine y value. Yep, root 3 over 2. Since you already gave me 1/2, I'll write it under cosine. And then cosine 45. Root 2 over 2. Sine of 45. Root 2 over 2. So now I've got, I know that both denominators are going to be 4, so I'm going to go ahead and just do this as one fraction instead of having to do extra writing steps. Root 3 times root 2, root 6, minus 1 times root 2 is root 2, and we're done. All right, we're going to backtrack because this section of problems doesn't have any cosine ones, and I want to do a cosine one, so I'm going to backtrack to number 14. The cosine of 105 degrees. So what two angles can I add together or subtract from each other to give me 105?
Just subtract.
Well, you can either pick two angles that you can add together and get 105 or subtract and get 105. 1645. So the cosine of 60 plus 45. So formula for cosine is cosine 60, cosine 45, opposite sign with cosine, so minus sine 60, sine 45. So what is the cosine of 60?
Half.
1/2. What is the cosine of 45?
Root 2 over 2.
Root 2 over 2. Minus sine of 60.
Root 3 over 2.
Root 3 over 2. Sine 45.
Root 2.
Root 2 over 2. So then, again, I know that the denominator is going to be 4. One on top. 1 times root 2 is root 2. Minus root 3 times root 2 is root 6. So see, in this case, it was just root 2 minus root 6 over 4. The other ones, I think the root 6 has pretty much been first. But it's the same. It's the combination of those numbers to know that it worked. I'm going to go ahead and give you problems, but they're not homework right now. You'll have, like Tristan, if you want to work on them tomorrow, since you won't be here Friday. For y'all, I'll let you work on them Friday. There might be one more thing that we do briefly on Friday, or I might just wait and do it on Monday with this section, where it's like kind of working backwards in a sense, where they start us here and we have to work the other direction. It's really easy, but that'll be kind of like the only thing. But I want you to work on going this direction first before we do the reversal. And if we need to see more examples, because obviously I kind of just did like one of each type or two, one or two of each type, but, we can work more examples or whatever. But tangent's obviously the hardest one to do. So let's see, some problems. 11, because that's the only way I can get a cosine one. 41, 43, and 49, which 49 is in radians. You're going to want to convert it to degrees. To do that one. And Tristan, I can go over tomorrow with you. Are you in class tomorrow? Yeah. Okay. I can go over with you what I will do with them on Friday tomorrow once you've worked through these problems. So that way you're still getting to see it in person. So,